Hi, welcome to the Unit 3.1 Periodic Trends video. So in this video, it's an introduction to the unit on periodic trends. And our goal for this unit is to utilize our understanding of periodic trends that we acquire in this unit and data analysis and interpretation skills to analyze a set of data on periodic trends. In this very first video, what we're going to cover first is the history of the periodic table. Then we're going to talk about what are periodic trends, and you'll see the several periodic trends in this video. Your objective in this video is not to understand why those trends exist, but just to get exposed to them and know what they are and be able to define them. Finally, we're going to talk about why this is important. So let's start off with the history of the periodic table. I want to introduce you to Dmitry Mendeleev. He is known as the father of the periodic table, so I guess you can sort of call him the Big Papa of chemistry. Let's talk about his contributions to creating the very first periodic table and how he did that. So what Mendeleev did was he noticed that elements have similar properties, things that you and I discussed in the previous unit. And he decided to sort or group elements with similar physical properties. So for example, if we look at luster, which is shininess, like elements that are shiny, which would represent a lot of the metals there, he grouped those together. And those that were dull, he grouped those together in a different group or section. He also grouped them by their atomic mass, so heavier elements were put in a section, lighter elements put in another. The formulas of the compounds that they form, and reactivity as well. So reactivity would mean things that are really reactive, like sort of like explosive. He would put those together, and those that weren't, he put those together. And he was able to create the first periodic table, which is shown here. And if you take a look, you'll notice that at the top there are 8 groups, and then there are 12 rows. Some of these there are blanks, like for example here there's a blank, and next to it is the atomic mass, and he left it blank because he knew there should be something there, but that element wasn't discovered yet. So after many more decades of research, we discovered more elements, we had a better idea of physical properties, etc. We utilized Mendeleev's first periodic table to sort of develop the periodic table that you know today. And just like with Mendeleev's periodic table, the periodic table that you know today, there are certain groupings of elements that have similar properties. And what emerges in both Mendeleev's and the modern periodic table are a set of trends in the periodic table known as periodic trends. So what does periodic and trend mean? Let's break that word down. Starting with periodic, it comes from periodic function, so that's something that repeats at regular intervals. And you can sort of think about this that there are class periods. In a class period, for example, on our anchor days, our class periods are 55 minutes. So period 1 is 55 minutes. Period 2 is 55 minutes. So there's a repeating pattern that each period is going to be 55 minutes. That interval of time is known as a period. A trend is a direction or change, so it's either things are either constantly increasing, constantly decreasing, or doing both increasing and decreasing. And one way to visualize it is by looking at a periodic function. So here's an example of a periodic function. You'll notice that this function, this plot, is there's like a pattern that's emerging. First it's decreasing, then it's increasing, then it's decreasing and increasing. So that repeating pattern of decreasing and increasing is a period. That interval is known as a period. So that's period 1, period 2, period 3, period 4. So that idea of finding repeating intervals is also evident in the periodic table. As you go across a row, you will notice that there are trends that repeat in the next row. So for example, if you go across period 1, there are certain patterns that repeat in terms of the atomic masses, like they're either all increasing or all decreasing as you go across the periodic table. As you go across period 2, the same pattern will emerge. So if the atomic masses are increasing in period 1, they'll also increase as you go across period 2. And the same thing for period 3 and same thing for period 4. And that's the reason why a row in a periodic table is called a period. It's because of this repeating pattern. So what are the periodic trends? There are several periodic trends. We can divide them into quantitative, those that have numbers associated with them, and then qualitative, those that do not. In this video, we're going to focus on these 5 periodic trends. We're going to learn what they are, and then you're going to analyze them in a periodic table and see if you can identify what the trends are. So let's start off with atomic numbers. Find this periodic table in your note packet. And what we're going to do is we're going to examine the trend that emerges as we go across a row in a periodic table. The atomic number, you remember, is the number of represents the number of protons, and those are the numbers that are shown at the top of these element squares. So what I want you to do is I want you to draw an arrow from the top of the periodic table going from left to right, sort of like the red arrow shown here. And then on top of the arrow, what I want you to write is what happens to the atomic number as we go across. Does it increase or decrease? So if you look at period 1, what happens to the atomic number? Do the same thing for period 2. What's happening to the atomic numbers? Okay, great. You should notice that they are increasing. So on top of that arrow, you should write the word increase. Now, in addition to trends that emerge as we go across a period, there are also trends that emerge as we go down a column or group. And the reason for this is that you'll notice that the periods are stacked one on top of another. So as we go down a group, there are also trends as well. These are known as group trends. So let's take a look at the group trend for our atomic number. You're going to now draw an arrow going down a group. And on that arrow, I want you to write what happens to the atomic number as we go down. So take a look at these atomic numbers as you go down a group. For group 1, do the same thing for group 2. What happens to the atomic numbers? Do they increase or decrease? Great, you should notice that they are increasing. So going across, they increase, and going down, they increase. So that's our first trend that you are going to learn. And this one's pretty simple because it's quite evident what's happening in your periodic table. All right, let's move on now to atomic radius. So atomic radius represents the size of an atom. And you may recall from geometry, the radius is the distance from the center of a circle to the edge of the circle. And even though atoms are spherical, they're three-dimensional, not circles, this model is sufficient enough for us to use to describe the size. So you'll notice that something that has a shorter radius, like this first circle here, is going to be smaller, and something that has a longer radius, like the second circle, is going to be bigger. So again, atomic radius just represents size, and the bigger the atomic radius, the bigger the size of the atom. Let's take a look at a periodic table that sort of shows that. Here we have a periodic table that's showing the relative atomic radii of atoms. And so all of these circles are representing basically different sized atoms. Now, before we go into looking at trends, you'll notice in the middle here, there isn't much change happening. So let's just ignore the middle portion. That's known as the transition metal block, and focus on these, which are known as the main group elements. That's group 1, 2, and 13 through 18. And what you'll notice in your handout is that I'm sort of going to push these two sets of groups together. So we just took out the middle block here, and that's what you'll notice here in your note packet. So find this periodic trend table. Okay, so what you're going to do now is you are going to do the same thing you did before with the atomic numbers. What patterns do you notice as you go across? Let's start with that. So as you go across, what happens to the atomic radius or size of the atom? Does it increase or decrease? Draw your arrow going from left to right, and then write that at the top of the arrow, whether it increases or decreases. Great, you probably noticed that they're getting smaller as you go across. So for example, you start here in A, which is sodium, to argon, which is much smaller. The numbers underneath, by the way, are the atomic radii. So notice that this is quantitative, there's a number associated with it. All right, let's try the same thing as we go down a group. As we go down a group, what happens to the size of the atom? All right, so if you draw your arrow going down, you would notice that the size of the atom increases. So along this down arrow, you should have the word increase. Okay, we just explored two periodic trends, so we'll notice that there are patterns that are emerging: atomic number and atomic radii. Let's go in now to electronegativity. Electronegativity measures the ability of an element to attract electrons in a covalent bond. That's a lot of information there, and it may not be quite clear. So the best way to think about electronegativity is sort of like two atoms playing a tug of war. And what they're playing a tug of war over, instead of a rope or a stick like these dogs, are two electrons. So atoms and bonds sort of share electrons, and in sharing those electrons, they're sort of playing a little bit of a tug of war. If the atoms have the same electronegativity, like these two dogs, you can think of them as being equally strong. So the electrons are going to be somewhat between them, because one is not strong enough to pull the electrons closer towards it. But in the case like with these two dogs, you have one dog that's much bigger than the other. So that dog is going to, it's sort of stronger, and it can pull the electrons closer towards it. And so when we say electronegativity, really you can think about it as two atoms playing tug of war. The larger the electronegativity, the stronger that atom is to pull the electrons toward it in a bond. Electronegativity is a very important concept, and so we're going to revisit this definition. But for right now, what we're going to look at are the periodic trends on electronegativity. So I want you to find this periodic table, and let's take a look at the trends that we notice that are emerging. These numbers, by the way, are electronegativity numbers. So, and the commas are actually periods. So for hydrogen, for example, electronegativity is 2.20, lithium is 0.97. All right, find this table, and then you're going to draw your arrow going across and then one going down. What happens to the electronegativity values? Do they increase or decrease? Great. So you probably noticed that they increase as you go across. Like for example, lithium is 0.97 and then fluorine is 4.17. So and as you go down, they get smaller. So hydrogen is 2.20 and then Fr francium is 0.86. Now there's one group that you may see here that doesn't have any electronegativity. Right, and that group is group 18. So there are no electronegativity values given for those groups, and you'll learn why later. But I'll just tell you for right now, it's because they're happy. They don't even want to bond with anything, whereas other atoms do want to form bonds. And we'll talk more about the whys later. But for right now, just know that this group here doesn't have electronegativity. Okay, so in the next video, we're going to go into the qualitative periodic trends that you're going to study.